Hey everyone, and welcome back. Today, we're going on a journey to the king of the planets, Jupiter, to uncover one of its most colossal and mysterious features. Now, I want you to do something for me. The next time you're outside on a clear night, look up at the full moon. It's beautiful, right? It seems pretty big in our sky. But what if I told you there's an invisible structure out there, belonging to another planet, that if we could see it with our naked eyes, would appear even larger than that full moon? Some say it would look twice the size, others even bigger. Sounds like science fiction, doesn't it? Well, it's not. It's science fact. We're talking about Jupiter's magnetosphere. So, what exactly is a magnetosphere? Think of it as a planet's personal force field. Earth has one, and it's incredibly important. It's generated by the molten iron core swirling deep within our planet, creating a magnetic field that extends out into space. This field acts like a shield, deflecting most of the harmful charged particles streaming from the sun, what we call the solar wind. Without it, the solar wind would strip away our atmosphere, and life as we know it couldn't exist. It's our silent, invisible guardian. Now, take Earth's protective bubble and imagine scaling it up to an absolutely gargantuan size. That's what you get with Jupiter. Jupiter's magnetosphere is the largest and most powerful of any planet in our solar system. It's so immense that it's considered the single largest structure within the solar system, second only to the Sun's own heliosphere, which envelops all the planets. Let's try to wrap our heads around the sheer scale of this thing. Jupiter's magnetic field is nearly 20,000 times stronger than Earth's. This field creates a magnetosphere that stretches an incredible distance between 1 and 3 million kilometers toward the Sun. That's up to 7 times the distance between the Earth and the Moon. But here's where it gets truly mind-boggling. On the side facing away from the Sun, the solar wind stretches Jupiter's magnetosphere into a long teardrop-shaped tail. This tail extends so far that it reaches past the orbit of Saturn. That's a distance of over 650 million kilometers. It's a structure so vast it literally touches the orbit of its planetary neighbor. If you could somehow make this magnetosphere visible from Earth, it would be a breathtaking sight. As I mentioned, it would appear larger in our night sky than the full moon. We wouldn't just be looking at a planet. We'd be seeing its colossal, invisible aura, dominating a patch of the sky. It's a humbling reminder of the epic scales at play in our cosmic neighborhood. So, the big question is, why? Why is Jupiter's magnetosphere so ridiculously powerful? The basic ingredients are similar to Earth's. You need a rotating planet and an electrically conductive fluid inside. Jupiter is the fastest spinning planet in our solar system, completing a day in just under 10 hours. This rapid rotation is definitely a key factor. The other part of the equation is the conductive fluid. On Earth, it's our molten iron nickel core. But Jupiter is a gas giant. It doesn't have a solid surface, and its composition is mostly hydrogen and helium. So where's the conductor? Scientists believe that deep within Jupiter, the immense pressure we read talking millions of times Earth's atmospheric pressure is so intense that it squeezes hydrogen gas into a state that doesn't exist here on Earth. It becomes a liquid metal. Imagine a planet with an ocean of liquid metallic hydrogen swirling around its core. This superconductive ocean, combined with Jupiter's blistering spin, creates the perfect conditions for a dynamo effect on a planetary scale. This dynamo is what generates the monster magnetic field. It's an engine of incredible power. Hidden deep beneath the colorful cloud tops we see in images from telescopes and probes like Juno. But here's the mystery that still keeps planetary scientists up at night. While this theory of a metallic hydrogen dynamo is our best explanation, it doesn't quite add up. Our models, based on what we know about planetary physics, can't fully account for the sheer strength of Jupiter's field. When scientists run the numbers, the observed magnetic field is significantly stronger than our current theories predict. There's a missing piece to the puzzle. Is the metallic hydrogen layer much larger or more conductive than we think? Is there something unique about Jupiter's core that we haven't discovered? Or is there some other physical process at play that we don't yet understand? These are the questions that missions like NASA's Juno spacecraft are trying to answer. Juno has been orbiting Jupiter since 2016, flying incredibly close to the planet and mapping its magnetic and gravitational fields with unprecedented precision. Its data has revealed that Jupiter's magnetic field is even weirder than we thought. It's lumpy and complex, with strange spots and variations, particularly in the northern hemisphere. It's not the simple neat bar magnet field we learn about in school. This complexity hints that the dynamo generating it is far from simple. It's not just a uniform, spinning ball of liquid metal. There might be different layers, strange weather patterns, or complex interactions happening deep inside the planet. Each new piece of data from Juno helps refine our models, but it also opens up new questions. We're peeling back the layers of an onion, and we're not at the center yet. This massive magnetosphere isn't just a scientific curiosity. It creates one of the most extreme and hazardous environments in the solar system. It traps charged particles from the solar wind and from Jupiter's volcanically active moon, Io, accelerating them to near the speed of light. This creates intense radiation belts, far deadlier than Earth's Van Allen belts. Any spacecraft or any future human venturing near Jupiter has to be heavily shielded to survive this onslaught of radiation. The electronics on the Juno probe, for example, are housed in a titanium vault to protect them. These radiation belts also produce the most spectacular auroras in the solar system. While our auroras are beautiful, Jupiter's are hundreds of times more powerful, and they never stop. They are a constant, dazzling light show at the planet's poles, a visible manifestation of the raw power of its magnetic field. So, next time you think of Jupiter, don't just picture a big, striped ball of gas. Picture a planet wrapped in an invisible force field of unimaginable size and power. A structure so large it would dwarf the moon in our sky, with a tail that stretches across the solar system. And remember that at its heart lies a profound mystery, a dynamo whose full power we still can't explain, pushing the boundaries of our understanding of how planets work. Jupiter isn't just the king of planets. It's a cosmic enigma, guarding its secrets deep within its stormy, hydrogen heart. Thank you so much for joining me on this deep dive into Jupiter's incredible magnetosphere. It's just one of the countless wonders our universe has to offer. If you enjoyed this journey and want to explore more cosmic mysteries with me, please hit that like button, subscribe to the channel, and ring the notification bell so you don't miss our next adventure. Let me know in the comments what other space topics you'd love to see covered. Until next time, keep looking up.